standard output. So using your bash scripting skills, you can just write a simple command that will first of all visualize what's in your file using zcat because it's compressed, and then you pipe that, and you want to echo the output of the line count divided by 4. So here because we are running it in Nextflow, we want to escape this $sign because Nextflow will interpret it as a variable that it uses. So we want to escape that because it's in a bash script, or it's in the shell. You can still do that in Python. I told you you can still do the number of read count in Python by implementing that in a Pythonic way. Python. Sorry. So there are some libraries you'll have to import because it's a compressed file, and then you can do something like you have to open the file, and read what's in the file. Then you loop through the lines in the file. So let me first of all define. I'll create a line counter here, just a variable to and then the number of reads. So as you know, a FASTQ file has 4 lines. You have the header, the sequence, then there is the quality scores, and the last line, which is it has 4 lines. So what we want to do here is count the number of those lines and then divide by 4. And in Python, you can use this this function here. I have counter. Counter divided by 4. Don't know if this will work. Let's see if this will work by faith. I'm getting an error, so I think I don't have gzip installed. .r, okay, I've seen where the problem is. I didn't put a comma in here. Yeah, you still get the same number of reads. So you can implement it both in Bash or using a Python script, or whichever method you're convenient, you feel more comfortable using.
John,
Yeah.
can you explain what this and
Yes. So when you execute a Nextflow script, first of all, you see it's executing it locally, and for every step, for every process, it is going to give you this. It's going to print this. So the first line here will correspond to the directory where the output of this process is going to be dumped. This is the process. It's called the num of lines, and it's just one file that you're processing there. So if we had multiple files, this number would change, and it gives you the status of the job, and finally it is just a single file, so it has worked on a single file. Once that process is finished, both processes can run concurrently. As I said, they are asynchronous, so it can run both processes at the same time. The same way for the second process. So if you look into your working directories, so by default it produces a work directory. If you look in your work directory, you're going to see those directories where the outputs are being stored. So if you look into the work directory, you'll see that there is a directory. Our processes were, the outputs are being stored in this directory. So we can look at the first one. Yeah, it's a long name. So here we see the inputs that, so it uses a symbolic or a soft link to show the input, but because we had instructed it to print the output on this on as a standard output, we can't get any file here. So the process process outputs are stored in a directory called work, and there are these unique identifiers which enable you to track the processes. But also, you can write that output in a specific directory when you specify using a flag called, let me just see. So you can specify the output using -help. Yeah, it's not giving me. Yeah, so in here we did not specify a parameter value for our output, but in the next exercise that we're going to do, you can specify the output directory, which in addition to being written to the work directory, the same results can be given out in an output directory where you can easily access. So the point here is just to show you that no matter which language you are using, you're still able to, I think, achieve the same results. So if you're using Bash or Python, you can still achieve the same results. And that's the beauty of Nextflow. But I think also Snakemake does that. But I think I'm in love with Nextflow. Yeah.
So the output, irrespective of the number of times that you run it, it's stored in a different location.
Yes, yes, yes. So if
E2, E5, E8, D2 is the location.
yeah,
E5, 5, E8, like
yeah,
address number or process number.
yes. So those are the identifiers for that particular process. As I mentioned, Nextflow allows you to track changes. So in case I've made anything to my script or to my task, I'm able to get it in a different directory as opposed to the initial directory which it had output the results. Yeah. You can still resume in case it was broken. You can use a flag -resume, which is reentrancy, to pick up from where it stopped. But it allows you to track any changes that you've made to your script. So that was the first task. I think it was a bit challenging because some of us may have forgotten simple stuff. Yes.
What are those Vincent, Rosalind?
Oh, that's just an arbitrary name giving your workflow a name. It's just a run name, so it's just random. Yeah. But
I
there.
think it's an easy one to remember than revision 911403D8 DC.
Yeah.
I'll just say, well, Vincent Rosary failed.
Mm.
It does this automatically, right?
Pardon?
The naming.
Mm-hmm.
It does it automatically.
Yes, yes, yes. It's automatic, and you see, it's using DSL2 syntax for this, because we're using the latest version of Nextflow, 22.04.0.
Specifically for those processes.
Yes.
So I think we saw the same with Snakemake. If you execute your workflow, you're going through multiple processes, and as Juma said, one of those processes fail. When you restart the workflow in the same directory, it will resume from the point of failure, and that's really important. So you can imagine where you have a workflow and you got what you might call an expensive process. That could be you're aligning 1,000 sequences, and thereafter you want to maybe draw a tree, and thereafter you may want to look through your tree and maybe root it, right? So the first two processes are expensive. Doing the alignment, you're going to do it the traditional way with mapped, not taking them over, and you don't have any reference. That can be really difficult. The other thing is that running trees, depending on the model, that can be expensive. You don't want to repeat that, okay? But maybe you may have a syntax error when it comes down to rooting your tree or counting the number of leaves in your tree. You may have a script for that. And that's the last step, but it's not the most expensive. So you don't want to, start from the beginning. So in your traditional bash script, if you don't do a certain error handling at the beginning of your script, where you want to raise an error so that your script terminates, your script may run with logical errors. Okay, and that can be really expensive because it means you don't know where the error is, you don't know at what point the error occurred. You just see inconsistent results, and you'll be lucky if you, if you're experienced, you'll know inconsistent results. If not, you end up, believing those are the real results. Okay. So Snakemake and Nextflow allow you to, start from a benchmark or a point, and resume from that point. Okay.
So you can attempt the rest of the exercises at your own time, or if we have time tomorrow, you can have a look at them. But yeah, that was just a brief snapshot of what you can do with Nextflow.
Nilikopi yako ikakata kufanya na yangu.
Gani ulikopi?
Hiyo Z card.
Z